Hey guys, and welcome to one more episode of Builder Nation. For today's agenda, we have the expert, Kimberly McGuire. She's a robotics engineer currently working at Bitcraze as a software developer, where she's making tiny drones fly by themselves thanks to artificial intelligence. So welcome, Kimberly. Super happy to have you here today.
Thank you for inviting me to this interview. So let me just quickly introduce myself. Well, you already did a little bit. So yeah, indeed, me being Kimberly, robotics engineer in Sweden. It's at a small company called Bitcraze, and we make and develop this small quadcopter. This is flying robot called the Crazy Fly. It's this small. It's very tiny, and that is pretty much being used for education and research. It's a platform where you can change all the software on it and all the firmware on it, so anybody can do their research on it or use it to teach students, like I was once myself, how to in all kinds of fields in control theory or robotics in general. They use this as well, or indeed autonomous flight. So yeah, all kinds of range of topics.
Wow, really interesting. And I mean, I was talking about your professional background a little bit earlier, and I noticed that you did not start, studying robotics. You started first as a design engineer or something like that, and then you changed it to mechatronical, and then you went into robotics. So how was that transition like?
Oh yeah, I've taken quite a detour, indeed. Well, maybe not necessarily a detour. I started industrial design engineering, which is, product design in that sense, like everything from designing UIs and UX design to how for instance, how a phone looks, how you interact with it. That was pretty much my bachelor's. At one point I decided that I would like to go a little bit more in depth on the technical side, so that's where I did some kind of bridging course in mechanical engineering, and then I did a mechanical engineer from a master's with a specialization in bio-inspired robotics. Yes, and after that I moved to another faculty called aerospace engineering. It was all at TU Delft actually, but I just hopped faculties, and that's where I started to take my robotics passion into the next dimension, namely the third. Because for my master's I was mostly working with a driving robot with moving eyes, but with flying robots, then you also have to think about like the aerodynamics and the control, how you can keep something like that in the air. So that makes it a little bit more complicated. And for my PhD, my topic was about making a swarm of these really tiny drones, like very similar to the Crazy Fly here, making them fly autonomously in a building to try to find other humans or something like that, if it was like on the verge of collapse, or to make a map or something like that. So that was kind of my final experiment. Then I started using the Crazy Fly for my research. Actually, I switched to it in the final year, and I loved it so much that I ended up working for them. So here you go.
Here you are, and you have been in Bitcraze like what, 3 years now?
Yeah, about 3 years. I started in 2019 in June. Then I attended with them also the ICRA conference, a big robotics conference in Montreal. Little did I know that only in half a year later we would be in some other situation where you couldn't go to any conferences anymore. But yeah, I've been part of Bitcraze for 3 years. It went by so fast.
I know, right? And how do you feel like at the industry? You have been, yes, in the engineering world for quite a while now, but jumping into specifically building drones, did you ever think that that's how you will end up?
Definitely not when I started my bachelor's, that's for sure. It kind of grew on me. So like at one point I understood that I liked robotics. So that's why I kind of tailored my master's to it. And I can very much remember the first time when I yeah, at least like I saw the people that were working with the current the product that I was going to end up at the MAV lab at TU Delft, and they were actually trying to fly a whole bunch of these swarm drones. And at one point, of course, you know, it was a little bit unstable. Some of them flew a little bit away. It was during one of these exhibitions, which I was also a part of with my master project at the time. And some people would look at that spectacle and say, maybe I shouldn't start with that. But I was like, that sounds like a challenge. And it was actually the same. Yeah, and it was actually the same people that I ended up doing like applied for my PhD project. So in the Netherlands, it's usually like a job that you would apply for. So and then I got it, and it was like they called it like swarm exploration with pocket drones. Just the name by itself already sounds very cool. So yeah.
Is there a way that you can explain to us, maybe like how will you build this drone? Like, what's the first step? First step, doing research. Second step, it's building your team. Third step is making the software, or how does it work?
The funny thing is actually, because it's such a small platform, you don't need to have a very big team to work with it actually. So like if you have much bigger drones of like a couple of kilograms or even larger, or these type of drones that would move vehicles, of course you would need to have an entire team, because you would need to think about safety. You need to think about like how can it fly outside, how can it, like, you know, meet regulations and everything. And at least for my PhD, I was pretty much working with this small platform by myself. Because it's actually so small, I can fly it in my kitchen. Yeah, so it's like the only thing that you might need to be a bit careful of are your eyes, of course, but like the chances of it running right in your eyes is very small. But even like, you know, these motors, they don't do any harm. So to answer your question, I would say is that you would start usually with the hardware. And luckily these are things that you can already buy from Bitcraze already. So then you would get like a nice little package, and then you have the motors, and then you would just assemble them. And luckily you don't need any soldering iron, so that's fine. So it's almost plug and play. But there's also a lot of other labs out there that would make the drones completely from almost from scratch, with like, you know, the motors here and the control board from some other stores. So, but luckily here it's all in one package. Yeah, and then after that, of course, that really depends, of course, on the drone. But then you would start looking at the software. If you're lucky, there's already some things that are already pre-programmed for you. If you're a little bit unlucky, then you have to start from basics. And first of all, it's something called like that you're able to control the attitude, which is the roll, pitch, and yaw. So usually any of these drones should have something called an IMU, an inertial measurement unit, where it's able to kind of determine in which orientation it is. Because by definition, this platform is a bit unstable. So if you would just like run the propellers randomly, it will of course flip over. So you would need to have a sensor in there that's able to determine in which orientation it is. So that's step one. And then you can at least control it with a like a joystick or something like that. So what you would see in like drone races and things like that. I'm a terrible pilot myself. That's why I make them autonomous. So and I think that's then the hardware, the motors, of course, the control board and the IMU. The second layer on top of that is that it would need to know its position. Because if you would let go of the controller with just like the lower level controller, it will kind of slowly drift away, or very quick, depends. And so it would need to have some extra sensors that's able to determine its position. So, and there's multiple ways of it to do that. Like we have, for instance, something called an optical flow sensor and a range sensor. So if you already put that on the bottom, like I did during my PhD research, then it's able to determine its own velocity. And then it's able to kind of like hover stilly in the air. And then you don't have to have a manual control to constantly keep it afloat. So that already makes things a lot easier. Yeah, so that's one layer. And then you have all kinds of, this is also kind of called a positioning system, but you can also think of other positioning systems. In Bitcraze, we've experimented with something called the lighthouse system, which is well, you can see it right here, probably not for the ones who are listening to the podcast, but it's a Steam VR base station that has infrared light sweeps that's exerted from. So if you're wearing a Steam VR headset for virtual reality, it's able to determine its position in space. So we kind of are doing the same with the drone. So we have this special deck on here that you can kind of attach or reattach. And with those sensors on top, it's able to kind of get the light planes from the base station and able to determine its own position. So then you're also able to make it fly. And then you would like to have a little bit more autonomy on top of that. So that you're able to do something with that position knowledge, because then you don't only want to hover in place, you also want to go from A to B. So then on top of that, then you will give it commands, or you will give it some symbols. They call it the state machine. It's like, for instance, if you would, that you have like it's kind of a robotics term. If you, for instance, want to just hover in place, but you have a sensor that kind of wants to avoid somebody, if it's in front of it, then you will have a state, okay, hover in place, unless you see something.
Oh my God.
And then the see something would be that it would move away or something like that. So that's, so you can start programming the autonomy on top of that, or you have maybe a camera that's able to recognize certain things and follow it. So those are kind of the three layers that you have to think about.
Oh, and I mean, you mentioned commands, right? Mm-hmm. How do you know how many commands you can implement into your robot?
Yeah, if you just get a robot completely from scratch, okay. Like usually what you would do is, of course, try to find the documentation. Okay. So that's I guess, like, I would never start with the like, if I just get a robot by itself, I would never, like, just start it up and plug my programmer in it and do everything that I want to. So like, if you would do that, for instance, on this, then you would actually ruin a couple of things that framework wise or architecture wise. So it's always good to go and look for a getting started guide. And luckily that's if that's the case, then it already means it's on a certain level that you're able to do something with it. But like, you also have Arduino, for instance. I don't know if, like, you're probably also aware of that. And that's, for instance, a little bit more bare bone, and it's really made for that you're able to do everything, but you have to kind of start everything from scratch. And if you would make a drone based on that controller, you would need to start with the attitude controller and this controller. And all those layers you have to build all the way from scratch. And that will take some time. So
and it depends on how complex you want the drone to be, right? Like how autonomous you want it to be. Okay.
Yeah, I would say if you want to have you want to start with more of a higher level of autonomy, like the going from A to B or recognizing things based on video images, then you would definitely need to find a platform or a drone that already has position control to a good level. It should be able to hover in its place, and you should be able to give it a command like go forward with 1 meter or maybe in 0.5 meter per second or something. It already has to be at that level for sure. So and it's also with swarms, by the way. Definitely not only with one. I would definitely say with swarms you would need to be able to trust not only one drone but also a gazillion drones flying next to you. So that even, I would say, even more holds if you're working with swarm robotics. But yeah, so that's kind of like the thing, is that you would need to kind of do some research and
And how many drones are we talking about when we mention swarms? Like, how many drones should I be imagining?
Well, technically with the Crazy Fly, the biggest drone swarm that we have seen so far is 49 in research, and I think that that was done by the University of Southern California. That's that's very impressive. And They
49
also
at the
built
same time. We're talking about
at
that
the
they're flying.
same time, yeah. So 49 at the same time. So they also did some optimizations on top of our own already architecture. Like we maintain quite a lot already in-house and as open source, but we maintain it. But they also made, for instance, communication that's a little bit more efficient. Because you can imagine if you need to send commands to each of these drones, you would need to make sure that the packets, the information packets that you send to them is small enough. And also you have to make sure that they already have a capable autonomy on board so that you don't have to say them every, let's say every 30 times per second, you have to tell them, oh, you now have to go to A and now to B and to C. Then you actually want to say it for like, okay, yeah, I want you to follow this approximate trajectory, for instance. And that's all you want to say to them.
Wow, this is definitely new technology.
Yes.
Why will you say it's important to make these swarms functional? Functional and easy to use.
Yeah, I would say that there's still a lot of fields can be discovered where they can be useful for. But if I would name several, is perhaps also like the use case that I used during my PhD research, that there's a building that's about to collapse and you want to have them fly right away through all the small windows and cracks and see if they're able to discover if there's anybody else inside. And other use case that I would think about are greenhousing surveillance, for instance. If you would have pretty big drones, it's for them maybe perhaps difficult to really go down to the plant level because of what they call downwash from the propellers. And that might damage crops. So in greenhouses, then you can have like a whole bunch of these flying around and check out if the crops are still in healthy condition, let's say. Yeah, and I would, you also have drone shows, of course. So it's like also a form of entertainment. Yeah, for like concerts or just the drone show by itself, I would say is already pretty impressive. So a form of art. And there's also some, so like experimental biologists sometimes use it also for flocking research to kind of see how that works, like how birds interact with each other. They try to reenact that for research. So that those are kind of like a couple of things that I would say that this is going to be quite useful for in both industry and research community. But I think there's definitely a lot of things still out there or fields out there that this might be useful for. So it's going to be interesting to see if it's anybody's going to apply for something completely new.
Probably. And I mean, now that you're in Bitcraze, I'm pretty sure that maybe you're closer to the purchasing process. How close are you? Like, do you tell your team or the other engineers like, hey, I need to buy this piece, or how does that process works, in a company?
Oh, yeah. That's actually an interesting question because like I said, Bitcraze is a pretty small company. We are only with 6 people at the moment.
Oh,
and we actually, our process is quite special to other companies. We are actually self-organized. So that means is that we each share like an equal amount of responsibility. So if I want to order a piece and I have consulted with enough people and everybody's pretty much like, not everybody, but like, most are okay with it, and I'm pretty okay with just ordering it, for instance. It's a pretty fast process, and like you can also see it, like we have quite a lot of products as well that for like, I think maybe for around the Crazy Fly, we have about like 15 other products and decks. We have 3 types of positioning system that we maintain, and that's only for a company with 6 people. And because we don't have to worry about the management layers, let's say, all the processes going very fast, and our innovation process also goes very fast. And well, also one fun thing is that we also have like something called like a 20% personal project time. So every Friday we have Fun Fridays. and then you can kind of work on a project, and it can be like, very much related to what you do at Bitcraze, but it can also be very little bit related what you do at Bitcraze. So it can either be like a start.
Personal, yeah.
Yeah,
I
exactly.
kind of actually saw that on your personal website, or I don't remember if it was yours, the personal one, or Bitcraze, but I was reading something, I think it was an article that it said like, we're getting a little bit slow in this process, we're pausing it down because we can only work on it on Fridays. And I was like, oh, this is really interesting, how it also, the company like allows you to work, step by step, but at the end of the day, you're building up something.
Yeah, it's definitely also for the start of new products as well. Like a lot of my colleagues are very interested in making new prototypes, so they'll be like all the way in their lab soldering away. I'm a little bit more on the computer side of things.
Okay.
So my Fun Friday project now is working on the Crazy Fly simulator.
Okay.
So, and that's a lot of fun to do. And even I would say, even if it's only one day a week, I still manage to get quite a lot done, especially if there's a lot of buzz from the community, and if they are like, I do get a lot of energy if I make something that I think that our community is going to find useful. So yeah.
And I wanted to ask you, I mean, since we're talking about building projects and developing drones, building up stuff from scratch, what has been your biggest technical challenge in your whole experience?
Biggest technical challenge. Yeah, that's very, very difficult question. I have to think about that. Like, it's because it has been quite a process. Like you said, going from industrial design engineering to like working with flying robotics. I wouldn't say like I'm pretty sure any technical challenge that I have found so far, I've managed to overcome them. I have, yeah. So like, it's just like a matter of like interest and work hard. And I think I can, for instance, like remember a course during my master's, and I think it was very artificial intelligence oriented or machine learning oriented, and I just didn't get it at first. I was like almost close to quitting, and I'm glad I did, because when I continued, I actually found the most interesting course that I had. I think perhaps maybe it's my biggest challenge. Maybe not. It's perhaps a little bit more vague than that. I think like, at least as a robotics engineer, I find myself like more of a generalist. Also, definitely with my industrial design engineering background, I also have like a lot of knowledge about like how important it is for things to be user friendly, like marketing as well, and from mechanical engineering to aerospace engineering. Like I'm not a specialist in any way. The difficult thing is, of course, is how to manage that and make that into like that's generalism into a specialty itself. How are you able to kind of like convey different items or different packages to kind of come together through integration? So that's like, perhaps a little bit more vague, but it's the, I guess maybe the general conception within robotics engineering is that, which is kind of changing, I think, is that everybody wants to hire a specialist that know only about one thing. So like, I know how to read out camera footage and, classify apples, for instance, or there's a SLAM expert out there, or I never want to call myself a SLAM expert or an AI expert or an embedded programming. Yeah, it's that. So that's kind of like, how do you portray yourself as a generalist robotics engineer and still like, definitely show that you have a lot of work of knowing the entire system instead of just a small thing.
Now that we're talking about this, is there anyone from the industry, any colleague that you admire, that you feel like it's an inspiration for you? Maybe it's someone, maybe in your PhD, you were like, I really admire this person, or I think that this project that X person is doing is amazing. Do you have anything like that?
Yeah, like definitely during my PhD, I would say that I definitely admire my professor at the time, Guido de Kroon. managed to like, still be so ambitious and still do research while he has like 3 children at the time when I was doing my PhD research. So that was like, and also like, yeah, and I think his wife was also a director at a company in Sweden. So that's also quite very ambitious family. So I would say like definitely like how he was able to handle that so quite well, I would say. Then yeah, there's a couple of this I would say also like fellow female engineers in area robotics as well. So and Enrica Soria from EPFL, she wrote a nature paper on with the crazy fly, and that was also quite like I talked to her, like I went to like I visited them at the lab of EPFL, and like just also her process of going through how to design this, like she really had to also kind of design from the autonomy from completely from scratch, and then to be able to publish in such a great journal paper. That's also great. And
now that you mentioned a colleague that it's a girl, that it's a woman, how do you think that nowadays we can, let's say, empower or let's say inspire? How do you think we can inspire other women to get into the industry, to not be afraid and to make them feel capable that they, as a woman, they can be in engineering?
Yeah, well, I think you have to start young with that. Like perhaps if I can make an example, here in Sweden, it's normal for high school students to come over to a company just like as an intern for 1 week. And we had one female student over there. And she was like, no, like I'm completely not strong with computers. Just give me some hands-on job. I'll do it. It will be fine. And at one point, we gave her some kind of task, which was a little bit boring, I would say. And at one point, I would say, hey, would you like to fly this thing? Yeah. So then I showed her like how to fly this drone manually first with the hand controller. And it's like, oh, she was actually quite a natural in it, I would say. And then I was like, do you want to do more? And then I showed her that optical flow sensor that you would put on there. And it's like, oh, just push there. And it's like, oh, it took off. It's like, and would you like to go more? And then I actually showed her like a script. And it's like, okay, if you change this line and this line, and the drone will start doing something else. And she just got it like that. It was amazing. And she said that she was not good in programming at all, but she had she had natural programming skills, obviously, because she knew how, at least a part of a script word, while she had never touched any programming line. I didn't start programming Python until my master's. Yeah, and then it was also like, yeah, I want to, and then she went all by herself, like, oh, I wanted to fly in heart shape. And then she just programmed it like this, like, and then she also told me she was not good in math. It's like, that, my friend, is geometry. Not good in math. No, but I don't know what it is, but it's not necessarily programming or like beta courses in general, like math and engineering type of things. And I think it's just a very misconception that women are not strong at it. It's weird. And I also not necessarily grew up, but I've been around a lot of engineering worlds where women were definitely not the majority. And then actually it's also kind of like painful to say, at one point you kind of start believing it yourself, that you still have to push yourself a little bit more extra in order to get recognition or something like that, or to because then it's a very difficult matter. But I think you have to kind of start already from high school, and just encourage those girls to start doing things for the RoboCup Junior, for maybe things like the join a robotics club, for instance, or programming club, or math club, maybe.
Geometry club, maybe.
Geometry. Yeah, I actually found that at my technical university, maybe not like the mechanical engineering and aerospace engineering, but are the technical math faculty had a majority of women there. So yeah, it was like, it's a very interesting contrast. That's why that, but that's engineering. Like, you're able to do this.
Exactly. I will say giving yourself the opportunity to do it. Probably that, and putting yourself in the right spot. You know, like
Exactly.
maybe try in Bitcraze and do your internship there or something like that, you know, like giving yourself the chance to explore, you know, something
Yeah.
else that you might not feel really comfortable at the beginning, but maybe you're a natural, just like this girl.
Yeah, exactly. So then you would yeah, that, like, if it's not for you, that's fine, and you've tried it, right? Like, then you can try to find other passion. But what if you actually are pretty natural at it, and maybe you might even like it. So yeah, that's kind of like the thing, is that you should just try it and not be worried that you might not be good at it, because that's why you
Because
try.
maybe you will end up working at Bitcraze as a software engineer. You never know. Wow. Okay. Thank you. Thank you, Kimberly. Any last advice that you can give to our audience, to all of the engineers who are listening to us right now?
Yeah, good advice indeed. Yeah, I would say, so, like, if you feel like a generalist yourself and maybe not the exact expert, like if you think that you have a little bit of knowledge of SLAM and AI and control theory and everything, don't think that you're less worth. You're actually probably the most important person in the company, or not.
Straight to the point, directly
Yes.
to the heart.
Don't doubt yourself. You're important.
Really motivational. Thank you, Kimberly. And thank you so much, Kimberly, for being here. Really, this was amazing. Thank you for sharing your experience with us. Thank you for being in Builder Nation. Is there any place where we can find you? Any social media? Probably your website.
I guess my website. I'm also quite active on LinkedIn, and I have also a Twitter. So I think, yeah. Shall I say that now, or shall you?
Go ahead.
Yeah, I think my Twitter feed is K_N_McGuire, and my LinkedIn is all together, so it's KN McGuire. So I guess, like, probably it will be written somewhere, part of this podcast. Yeah, and from there you can pretty much go to my website, which is KN McGuire at Bitcraze.io, and I definitely also recommend just to go to Bitcraze.io as well, which is mostly like where I have most of my blog posts that is related to either the Fun Fridays or the things that we do within Bitcraze.
Okay, amazing. Thank you so much, Kimberly. Thank you so much for being here as well. And remember, guys, that you can also find more information and interesting articles, interviews just like this one with Kimberly in our website, ControlHub/Builder-Nation. We will be super lucky to have you there. And thank you so much for being a part of this community. Thank you so much, Kimberly, for being here. It was an amazing experience.
Thank you for inviting me.